Hello again, algebra students. This mini lesson is on how to work with complex fractions. I know the name might sound a bit scary, but hopefully we can break this down for you so that complex fractions are something that you can deal with on your own. A complex fraction is sometimes also known as a stacked fraction. The idea being that we have fractions over fractions with other fractions and other fractions. So we've got a lot of numerators and a lot of denominators to look at the moment. We want to simplify this to the point where we have one denominator and one numerator, and that's it. Make it look as simple as possible. Now, there's actually two ways to go about simplifying a complex fraction such as this, and in this video we're going to show both methods. It's then up to you to choose whichever one works best for you in a particular situation. The first method, as I look at this expression, I can focus on just the numerator or just the denominator. So focusing on just the numerator first, we are asked to take 3 divided by x minus 2 minus 6 divided by x squared minus 4. So what I'm going to do first is cover up the denominator so I don't worry about it. I'm focusing on just the numerator and what I can do to simplify this as much as possible. Well, this goes back to some of the things we practiced in earlier lessons, subtracting two rational expressions with different denominators. So let's put them together. If we find a common denominator, I should probably start by finding factors of this expression here. X squared minus 4, I could rewrite that as x minus 2 times x plus 2 using the difference of squares factoring pattern. Now that I know what two factors make up this denominator, I can look at the two fractions and say pretty confidently that x minus 2 times x plus 2 is the common denominator that I want. That said, we have an x minus 2 as a factor in this denominator. That means we're missing the factor x plus 2. I'll go ahead and multiply both numerator and denominator by that expression. After I do that, I'll distribute the 3, which gives me 3x plus 6 minus whatever comes next. Well, the expression on the right already has the denominator that I want. I don't have to multiply by anything. So I know that I'm going to have 3x plus 6 minus the 6 that I see for an expression there. Now, this will make up my numerator over this common denominator. Before I write it, I'm also going to simplify the numerator by looking at the common the common terms of 6 and negative 6. We can go ahead and add these like terms together, which is going to be 0. So, the numerator of the large complex fraction, when simplified, will look something like this. 3x plus nothing is just 3x over the common denominator, x minus 2 times x plus 2. I'll go ahead and rewrite that in red so we can see it matching up. So, at least our numerator of that large complex fraction is now one fraction instead of 2. Our next step is to do the same thing for the two fractions that I see in the denominator. Well, looking at these two fractions, I see one as a denominator of x plus 2 and the other x minus 2. Putting those together, I'm pretty sure that my common denominator is going to be the product of these two things multiplied together. So I think that for a common denominator, I will need, we'll use red, x minus 2 times x plus 2, because that's the two of these multiplied together. Now, if that's the common denominator that I want, I see that I'm missing the factor x minus 2 from the fraction on the left, and I'm missing the factor x plus 2 from the fraction on the right. Notice now that we have the same denominator underneath each fraction, so when we add them together, we'll have that denominator. Then it's a matter of putting the numerators together. Well, 3 times x minus 2, if I distribute the 3, that's going to give us, and I'll write it down here, 3x minus 6. Taking the 1 and distributing it to an x plus 2 isn't going to change anything. It will just be x plus 2. And I was adding, so I'll put a plus sign in between those expressions. Again, these make up the numerator that I'll write over there in just a second. Well, before we do that, we're going to add the like terms together. 3x plus x is 4x. And negative 6 plus 2 is negative 4. So what we have on the right now is still a complex or stacked fraction. I have a fraction in the numerator over a fraction in the denominator. But at least at this point, I have one fraction over one fraction. Now the way that we can interpret this is I have a fraction divided by another fraction. And if you remember, when we divide fractions, instead of dividing by a fraction, we multiply by the reciprocal. That's going to be the next step that we take. Now it's a lot to look at, so I'm going to rewrite this so we have a little bit more space to work with. So, rewriting our numerator, 3x over x minus 2 times x plus 2. Instead of dividing by this fraction, we're going to multiply by the reciprocal. So I take this, flip it over. The numerator will be x minus 2 times x plus 2, and the denominator will be 4x minus 4. Now I'm multiplying two fractions together. Well, if I'm multiplying, I can cancel or divide out any common factors. I see that I have a common factor of x minus 2, and again, this is all multiplication, so this is okay. X minus 2 cancels. X plus 2 cancels. That's going to leave me with 3x in the numerator and 4x minus 4 in the denominator. I now have one fraction with one numerator and one denominator. I have finished simplifying that original complex and scary looking fraction that we started with. Now that's method one. If that works for you, add the 2 in the numerator together, add the 2 in the denominator together, and then instead of dividing, multiply by a reciprocal. Simplify as much as you can. Method 2, which should give us the exact same result, is to look at all of the fractions that make up our complex or stacked fraction and pick out the least common denominator of all of them. So looking at all four denominators, I see x minus 2 here, I see x plus 2 here, so I know that I'll have to have at least an x minus 2 and an x plus 2. X minus 2 is repeated down here, I don't have to include it twice, it was already taken care of there. And finally, the x squared minus 4, remember when we factored that, it was x minus 2 times x plus 2. Again, those are the two factors that I already see represented by other denominators elsewhere. So as I look at the four fractions, I'm pretty confident in saying that x minus 2 times x plus 2 will be the least common denominator of each of these four fractions. If that's my least common denominator, and it is, what I'm going to do next is I'm going to multiply the entire complex fraction, all of it, by that least common denominator, which was x minus 2 times x plus 2. Now when I multiply every expression, the entire complex fraction by that, it's each individual part of this is going to be multiplied by that same common denominator we came up with, x minus 2 times x plus 2. Now watch what happens when we do this. When I take x minus 2 times x plus 2 and multiply it by 3 over x minus 2, and again, you can imagine this is this over 1. I'm multiplying these two fractions together. Any common factors I can divide out or cancel. So I notice that I have an x minus 2 over an x minus 2. Those are going to cancel. No more denominator. I just have 3 times the x plus 2. I'm going to write that over here. 3 times x plus 2. So that takes care of the first part of it. Minus, I take x minus 2 times x plus 2 times the second fraction that I see here. Well, remember that x squared minus 4, that's the denominator I have here. That's the same thing as x minus 2 times x plus 2. That said, the entire thing will cancel. X minus 2 times x plus 2 divided by x squared minus 4 is going to be 1. It goes away. So there's nothing to multiply 6 by except maybe 1, which won't change it. So we're going to have minus 6 over here. My numerator is now a single line of algebraic expressions. That's pretty nice. We'll do the same thing with the two fractions in the denominator. I multiply by 3 over x plus 2. Well, that means the x plus 2's will cancel. and I'll have 3 times whatever's left over there. Well, that's an x minus 2. Now for the fourth and final fraction. X minus 2 in the denominator here, x minus 2 in the numerator here. They'll cancel, and it'll leave me with 1 times x plus 2. All of this has now been simplified to the expression we see over here in blue. I've got 1 numerator over 1 denominator. Might be a quicker and easier way of doing it, but you would have to find least common denominator and know how to multiply this all out. So again, it's not for everybody, but for some it might be a little bit more of a shortcut method to doing this. Finally, we do need to simplify numerator and denominator. I'll simplify the numerator by distributing the 3, which will give me 3x plus 6, minus 6, all over. And the denominator will have 3x minus 6 plus x plus 2. We'll combine like terms in both numerator and denominator. 3x plus 6 minus 6 is 0, so 3x is the numerator. In the denominator, I have a 3x plus an x, which gives me 4x, negative 6 plus 2, which is negative 4. I have 3x over 4x minus 4 for a final answer. The exact same thing that we got using the first method. So again, whichever method works best for you, whichever one you understand better, it's up to you. But you should be able to come up with the same final answer no matter the method that you use.